All right, when we talk about polygons, what we're talking about there, that's just the broad category for the shapes, different number of sides shapes that we could have, like a triangle, pentagon. They're all grouped under this group called polygons. And so let's, they're the shapes that are made up of straight line segments. And so yeah, we'll of course start with the triangle, 3 sides. Now, when we go up to 4 sides, well, you might be thinking square, but not all 4-sided polygons are squares. Not all 4-sided polygons are rectangles either, if you're thinking that. No, and we'll talk about more specific examples here of triangles and this. Quadrilaterals is the big grouping term for 4-sided figures. Yeah, rectangles, squares are in that group, but there's others as well. So we'll talk more about those in a second. All right, then you've got, of course, 5 sides is the pentagon. Hexagon is the 6-sided polygon. Heptagon is 7 sides. Octagon is 8. Nonagon is 9. Decagon is 10. And the other one that we mentioned here is 12, dodecagon. It's got 12 sides. So those are there's of course others, but those are the ones we want you to be familiar with. And we'll talk about more later on. Now, let it be said here that usually when we think of a pentagon, we think, Pentagon in Washington, D.C., I guess, but yeah, we usually think, that's not my best rendition, but yeah, we usually think the ones that have the same sides all the way around, right? This side's the same as this side, the same as this side, the same as this, same as that. That's, of course, called a regular polygon, or in this case, a regular pentagon. If all the sides are the same and all the angles are the same, it's called regular. All sides equal, and for that matter, all angles equal. Those are regular polygons, pentagon, hexagon. But does a pentagon have to be regular? No, it can be quite unregular, I guess you might say. Yeah, it doesn't have to be regular, that one. This side, though. Okay, 5 sides. Yeah, that one's got 5 sides. Should be 4 first of all. Yeah, it's got 5 sides, but it's still a pentagon. It's just not regular. Obviously there. So usually we think of the regular size. We'll talk more about those things later on. Just be aware of those. Okay. Yeah, the other thing here I wanted to spend a little time on. Well, one thing on the triangles is there's different types of triangles. There's different types of quadrilaterals. So let's just talk about those types of triangles a little bit here. One thing we can do, before I do that even, another thing about triangles, and so for triangles, the sum of the angles is always 180 degrees. The sum of the angles of a triangle is always 180 degrees. So if you add up the angles of any triangle whatsoever, so let's say this one's 70, this one's 40, no, say it's 30. This one, so 70, 30, so this one have to be 80. They always add up to be 180, okay? Always on a triangle. There, and it's fairly easy to see. I don't know if you've seen this before, but if I take my pen here, the tip's pointed that way. So if I rotate this, if I go to 70, all right, then if I go add that 80 to it and then add the 30 to it, you see what happened? It flipped 180 degrees, didn't it? So it's not too hard to see that, but anyway, that little fact, and we'll explore more on that a little bit next time, I think, but it'll help us on some of these. Because on the types of triangles, we can group the types of triangles by the angles in them, by the classify them by angles. All right, and so number one on this classification is you've got a right triangle, which by the name, of course, you get the fact there that, yeah, it has a 90-degree angle in it, it has a right angle in it. Now what I mentioned on that is, what about the other two angles? If we've got one right angle, what are the other two angles? Well, they have to add up to be 90, don't they? And so the best, you can't really say what the other two angles are, but you can say that they're acute, right? So you've got, yeah, you've got a right angle, but you've got, the other two are acute, they're less than 90. All right, then, of course, you've got the obtuse triangle, has a obtuse angle in it, which again, the other two angles are acute, but one of them is obtuse, greater than 90. All right, then, so you've got, both the other types here have two acute angles, right? One right, two acute, one obtuse, two acute. Well, the third one is just an acute triangle because it's all three angles are acute, less than 90. Of course, the easy ones to do that is the one where they have all angles the same, but all angles are acute, that's an acute triangle. But then we can do classifying of triangles by sides. All right, and so of course, if we have all three sides the same, that's the equilateral triangle. All sides equal. So this side equals this side equals this side. All right, then number two, if you've got two sides equal, that's the isosceles. Good example of that one. You got these two sides the same, then of course this side is a different length there, so that's isosceles. And then, of course, that leaves, last but not least, when no sides are the same, what's that one called? Scaling. So yeah, you've got one side, and then you got another side, and then another side, so they're all three different. That's scaling. All right, now. So let's classify these triangles here by both classifications. All right. I'm not sure if they actually have you compute any angles here, but like I said, we know that the sum's 180. So let's say we've got this one is 43 degrees here. This one's 46 degrees. All right, so a couple of things we would need to know for that is, of course, this angle right here, since it's not given, like I said, I don't know if they actually have to compute, but if we did, that angle right there would have to be 180 minus the other two, right? Which that's going to put it at 91 degrees. So that makes this one, that's an obtuse angle, isn't it? Bigger than 90. So this is an obtuse triangle. And, oh, okay, so the other thing is, are any of the sides the same here? The sides are all different because the sides are proportional to the angles. So if the angles are all different, so are all the sides. So it's scaling. All right, so you have to compute those. All right. Now, the other thing I was going to get to here is the classifying the quadrilaterals. So let me do that real quick here. There's three different classes of quadrilaterals. We could group them in. And we do those by parallel sides. Of course, if you've got two pair of parallel sides, you've got a parallelogram. Two pairs of parallel sides. And the one we usually think of, parallelogram, was like that, where these sides are parallel and so are the top and bottom. There's other variations of that, but if you've got two pairs of parallel sides, that's a parallelogram. And you have one pair of parallel sides, that's a trapezoid. And we usually think trapezoid like that, but that's also a trapezoid there. Yeah, as long as you've got parallel sides, that's a trapezoid. So in here, in this case, the vertical ones are the parallel ones there. Which leaves one other class, and that is trapezium. That's no parallel sides. The easiest one to draw those is like a kite shape. There's other, doesn't have to be a kite, but that's the easiest ones to draw. But no parallel sides, that's called a trapezium. Now, let me ask you this. Where does rectangle and square, where do those fit under? It's got to fit under one of these. Well, aren't rectangles and squares parallelograms? Yeah. Squares are parallelograms. It's just that they're all sides the same. You've got right angles. A rectangle, actually, square would fall under that category. But a rectangle is also a parallelogram. It's just that it has 90-degree angles. Both sides are parallel to one another. There's a side. And then there's one other one, and it's called the rhombus. It's also in the parallelogram category as well. But the deal on the rhombus is it's a parallelogram with all sides equal, which a square is an example of that, but it doesn't have to be a square. A rhombus is just all sides are equal, parallelogram with all sides equal. So those are the groupings of quadrilaterals, so I want to get to that.